Welcome to my second part of lecture on numerical analysis. So today I will discuss about the Newton's forward interpolation formula. And I have to mention that in Newton's forward interpolation formula we will use the diagonal difference table. So let us consider y equal fx be a function which takes the values say y0, y1, y2 up to then yn for the corresponding argumental values x0, x1, x2 and xn. And here it is notable that the differences between any two values of x is same. That is xn minus x n minus 1 equal to x, where n goes from 1 to 3. So I mean that they are equidistant. The values of xi are in equidistant mode. So now as earlier I have told that the function sometimes we may not handle. So then this function now can be replaced by another polynomial. So phi x. And replacing of a function by another polynomial rests on two theorems. It is given by Stress. And now say the polynomial phi x is written in the manner that is say a0, a1, then x minus x0 plus a2, x minus x0 and x minus x1 plus a3, x minus x0, then x minus x1, x minus x2 and so on. And the last term is say an and x minus x0, x minus x1, x minus x2 up to then xn minus 1. So here these a0, a1, a2 up to then an are constants. And they are chosen in such a way that it is then an equal to it is then yn equal to phi of xn. Constants are chosen in such a way that this yn equal to phi of xn. So now I will determine these coefficients one by one. And for doing this, first I will put say x equal to x0 in equation 1. And if I put x equal to x0, if I put x equal to x0 in 1, then I will get this is phi of x0 equal to, this is by this definition, so it is then y0, and on the right hand side it is then a0. And you see, if I put x equal to x0 here, so this is 0, means that all other terms 0 except this a0. So therefore I am getting a0 equal to y0. So here I am writing this first coefficient a0 equal to this is y0. Next, I will put x equal to x1 in 1. I will put x equal to x1 in 1. Then on the left hand side it is then phi of x1, and by definition it is y1. And then on the right hand side it is then first term is then a0 plus a1 and it is x minus x0 and other terms are 0 because this x1 minus x1 it is 0, similarly other terms are 0. Now I can put the values of this a0 as well as this x1 minus x1. And then this is phi of x1 is equal to y1, already we have this. So y1 equal to a0 equal to y0 plus a1, and the difference between x1 and x0 is h. So it is then h. So on simplification we will get this is a1h equal to y1 minus y0. y1 minus y0 y1 minus y0. Then if I divide it by h, a1 equal to, I will get this y1 minus y0 divided by h. And by the definition of our difference table, so then this is delta 1 means that you do not write the first suffix y1, and then this is delta y0 by h. So then I am getting the value of a1, the second coefficient, as this delta y0 by h. So then a1 equal to So it is then delta y naught by h. So next, to determine A2, we will put x equal to x2 in equation 1. That is, I am getting phi of x2 equal to, this is A0 plus A1, and then this is x2 minus x0 plus, it is an A2, it is an x2 minus x0, x2 minus x1, and other terms are 0. And other terms are 0. Now I'll put this value one by one. So on the left hand side, it is y2, and A0 is equal to y1. So A0 equal to y0 plus A1. So A1, I can put the value A1 equal to, it is then delta y0, means that y1 minus y0, divided by h. And then x2 minus x0, the difference between x2 minus x0 is twice h, because there are two steps. From x2 to x1, first one h, from again then x1 to x0, another h. So altogether there are two h. So it will be multiplied by twice h plus a2. So this is twice h and then h. Now you see that is h and h will be cancelled. Now I can simplify it. So on simplification, we will get A2 equal to, this is y2 minus 2y1 plus y0 divided by 2h square. And already we know that this y2 minus 2y1 plus y0, so this is equal to delta square y0. So then this is equal to delta square y0 by 2h square. So this is the value of this A2. This is the value of A2. Actually, after computing the value of A3, we will observe that this will be actually the factorial. So next we will compute this A3. And to compute A3, we will put x equal to x3 in 1. So this is the value of this A2. Now I'll put the value x equal to x3. I'll put the value x equal to x3 in 1. That is, on the left hand side, it is then phi of x3 equal to, this is A0 plus A1, it is x3 minus x0 plus A2, x3 minus x0, x3 minus x1 plus, it is an A3, then this is x3 minus x0, x3 minus x2 and x3 minus x. x3 minus x, so it is 1 and this is 2. Okay. So next I can put the values, corresponding values. So if I put the corresponding value, then on the left hand side I will get, this is y3. This is y3. Equal to then A0. A0 means it is then y0 plus A1. A1 means it is delta y0 by h. So delta y0 by h means it is y1 minus y0. It is y1 minus y0 divided by h. And then x3 minus x0. So then this is 3h. There are 3 steps. Plus A2. A2 equal to, it is then y2 minus 2 y1 plus y0 divided by 2h square. Then this is multiplied by, you say this is the 3h and this is all 2h. So this is 3a's and into 2a's plus I am coming to this term. So then this is A3 plus A3, then this is 3a's, then this is 2a's and into h. Now these h and h is cancelled. Similarly ac square, there are 2h, so this is cancelled. And similarly this 2 is also cancelled. So after simplification, so we'll get A3 equal, it is then 6 is cube, it is then y3 minus 3y2 plus 3y1 minus y. And from the definition of divided differences, so we are getting the numerator as delta cube y naught, and 6 means it is 3 factorial. So it is then 3 factorial then is cube. Now we can continue this process of computing the coefficients. So therefore I can get A4 as this is 4 factorial is to the power 4, and in the numerator it is delta to the power 4, and then this is y. So similarly, I can compute the last coefficient an. So then if I continue in this way, so this is 0. This is 0. Similarly, I can compute this an equal to this is delta to the power n, and then this is y naught by n factorial and h to the power. So after this, I am getting all the coefficients. I am getting all the values of these coefficients. Now I am going to put these values in the equation 1. So I will put the values of A0, A1, A2 up to an in the equation 1. So then I am getting this phi x is equal to A0 means it is y naught plus A1 means it is delta y naught. It is delta y naught divided by h, and then x minus x naught plus it is then A2 is equal to delta square y naught by 2 factorial, and this is h square, then x minus x naught, x minus x1 plus, now I am putting the value of A3. So A3 is equal to delta cube y naught by 3 factorial is to the power cube x minus x naught, x minus x1 and x minus x2. Similarly, I can put the other values A4, A5, etc. and I am putting now the last term. This is an equal to delta n y naught divided by n factorial and h to the power. And the term set, this x minus x naught, x minus x1, x minus x2, and the last term x minus x n minus 1. Now I will define one variable. One variable u is defined as x minus x naught divided by s. Means that this first term, x minus x naught divided by s. I am defining another variable because x is a free variable. So means that this now the variable becomes this u. So now first term is this x minus x naught divided by s is equal to u. Then what will be my second two terms? So then I can distribute this x minus x naught divided by s, and then again x minus x1 divided by s. So now simplify it. So first term is already u. Next, then, and what is x1? x1 means x naught plus h. x1 means it is x naught plus h. So I can put this value here. So therefore this x minus, it is then x naught plus h divided by h. So then this is equal to u, then it is x minus x naught divided by h, then minus h by h. So then again this value will be equal to u, and this is h and h is cancelled, so it will become 1. So then ultimately we are getting as this is u then into u minus 1. So similarly, if I compute this x minus x naught, x minus x1, x minus x2 divided by h cube, so then I will get this u into u minus 1 and u minus 2. So this term I will get as, this is u into u minus 1 and this u minus 2. So similarly, the last term x minus x naught, x minus x1, x minus x2 up to x minus xn minus 1 divided by h to the power, then I will get this u minus 1, u minus 2 up to then u minus n minus 1. That is, the term becomes this u and u minus 1, u minus 2, then last term is then u minus, it is then n minus 1. So now I can put this value in this equation. Say this equation may be named as 2. So I can put this value in the equation 2. And on the left hand side, this you say this x will be now written in terms of u, because already I have defined u equal x minus x naught divided by a. So this implies this is x minus x naught equal to HU. So that is x is equal to x naught plus HU. So means that now this phi of x will be replaced by phi of x naught plus HU. And then it is a function of u, so then we can rename by another function, say psi of u. I am writing here as this. So this is phi of x naught plus HU. And I can rename it as say by another function, say because it is only a function of u. So then this is a function of u, say this is psi of u. And on the right hand side, this is, first term is this is y naught plus it is delta y naught then u. Okay. So then I am writing the coefficient first. So this is delta y naught then u plus it is delta square y naught by 2 factorial. Delta square y naught by 2 factorial. Then this is u into u minus 1 plus the coefficient is x delta cube y naught by 3 factorial. It is then delta cube y naught by 3 factorial u into u minus 1, u minus 2. And the last term, this is delta n y naught divided by n factorial, and it is then u minus 1, u minus 2, and then up to then u minus n minus 1. So this is the Newton's forward interpolation formula. By using Newton's forward interpolation formula, we can compute the value of a function which lies within the upper half of the given table. Means that, say we have given the values of y0, y1, y2, y3, y4. So we have now here 5 values. So this is the middle value. So y2 is the middle value of this given table. So then Newton's forward interpolation formula can be used to determine the value of the function which lies in the upper half of the given table. Means that if the value we have to evaluate lies in the from y0 to y2. For determining the value below this y2, we have to use the Newton's backward interpolation formula. So always we have to keep it in mind that for Newton's forward formula, we can use to compute the value of the given function which lies in the upper half of the given table, or in sometimes before the initial value of the given function. So this is the Newton interpolation formula. I hope you have understand it, and if you like it, then you share the video to your friends. Thank you for watching.